12.1 is about tangent lines, and this theorem talks about if AB is a tangent to O at point P, so AB tangent to the circle, you know that OP is perpendicular to AB, so it forms a 90-degree angle. So when we look at problem 1 here, they tell us that ML and MN are tangent, giving us the fact that those are right angles. So if we're trying to find x here, this is a four-sided figure. It's just a kite, basically. So we have a four-sided figure here that you're going to just take x plus 90 plus 90 plus 117 equal 360 degrees. Why? Because it's four-sided. Combine your terms, you get x plus 297 equals 360. Subtract the 297 from both sides, you end up with x equals 63 degrees. Here you're trying to solve for the radius. They're giving you a tangent line, another line here. This is radius. So again, this is a right triangle because it's a tangent line up top. So our hypotenuse, which the whole hypotenuse is x plus 8, that squared equals x squared plus 12 squared. So now we're going to do a little bit of algebra, and we're going to square this out. Now, you could write it out and you could FOIL it, but let's use our shortcut where you take the first one, you square it, you combine the middle two and double it, so 8x becomes 16x, and then you square the last, which is 64, equals x squared plus 144. Okay? Now you're just solving. Well, let's move something first. We got to usually get it equal to 0 if it's x squared. So let's go ahead and subtract here. X squared, that cancels. Oh wait, that cancels as well. So since x squared is gone, this kind of makes my life a little bit easier. 144. Now let's solve. Subtract 64 from both sides. That gives me 16x equals 80. Divide by 16. X equals 5. So my radius is 5 in this particular case. Problem 5 is they want to find the perimeter of this triangle ABC. So let's call it A here, B here, C here. So we have this triangle. We have got to find the perimeter, so I need the distance all around. What's kind of nice is they give us little portions of the tangent. We know that if a point's outside, if it's 15 from B to this point right here, let's call it, I don't know, D, it's going to be 15 also to this point right here. Let's call it E. So this is also 15. Okay? And then let's call this point right here where they intersect F. If CF is 8, CE is also going to be 8. And if AD is 10, AF is also going to be 10. So if you stay on the same side of the circle, it's pretty easy. How do I find the perimeter then? I just go ahead and add up all those, and my perimeter is going to be 10 plus 10 plus 8 plus 8 plus 15 plus 15, which is going to end up giving me 66 is my perimeter once I add up all those problems.